All right, so meet the Raspberry Pi. So today, this is not a technical session at all. It's what is a Pi, who is the company, and what can you do with it. That's basically what we're going to cover. As I just mentioned before I hit the red button, I'm a web developer, have been for 30 plus years. I've been doing Drupal work for the last 15 or so. Any Drupal people here? No Drupal people. Okay, that's all good. I started a podcast about Drupal 14 years ago. It's still running. We're in episode like 450.
Wow.
So if you're interested in learning about Drupal, you can go back and see what I thought about Drupal 12 years ago. I started episode 0. Um, and I would call myself a Linux and Raspberry Pi enthusiast. My website there is stephencross.com, and today's presentation is there, slash today is a PDF file. So, a very brief history of me. I was a Mac fanboy for 15 years, did everything Mac for a long time until they came out with this thing called a Mac Mini, which I said, let me give this thing a try. And I put it on my desk next to my Gateway PC running Windows, and within 2 weeks, I was like, okay, this is a better place for me to be. I switched over to all Macs. Kids had Macs. House was all Mac. Didn't have any PCs anymore. Until about 2017 and 18, when I bought my first Raspberry Pi, and I started playing with Linux. And then I did the same kind of thing I did with the Mac. I bought one of those little, like a Nook size PC, installed Linux on it. Within a couple of months, the Mac was gone, and I switched over to Linux. So I'm a full time Linux person, have been for a while. I still do have a Mac on my desk. I use it for video producing, um, but most of all my day is Linux. I don't think I'll ever switch again. We'll see. Um, so I bought my first microcontroller, which we'll talk about those in a little while, in 2020. So this stuff kind of is all new to me a little bit. 5 or 6 years been playing with these things, and just think they're fantastic, as you'll see today. Let's start with really basic question: what is a Raspberry Pi? So it's a single board computer. They came out in 2012, so that'd be 14 years ago, and it's a fully functioning machine as the original one. This is the original here. I'm gonna pass these around. You guys can hold these if you never have or play with them. My wife always wonders why I'm like staring at these things a lot. I think they fascinate me. But this is the very first one. I didn't buy it when it first came out. I already told you that. But I bought this on eBay maybe 2 years ago for like $14. Um, and I actually booted it for the very first time about 2 weeks ago, wondering if it still ran, how it ran. I never used one that was at this age, so it was an interesting experience. I'll talk a little bit more about that later. So this is a Pi 1. These are, they call them credit card size computers. You also see that, but that's a little bit bigger than a credit card. But that's about the size. And these are fully functional machines. So this is like the original, and this is the most recent Raspberry Pi 5. And if I didn't have this little heat sink on top with a fan, it would look exactly the same. It would look like this. You can't really tell the difference unless you know what you're looking for. This is a Raspberry Pi 4. But if you'll notice here, it's got, USB ports. It's got an Ethernet port, has a Wi-Fi connection, has two HDMI ports, and it has a power port. So all you need is a keyboard and a mouse and a monitor, and you can plug this in, and you have a working computer. I mean, the last line here is an important one. Um, it's one I'm going to go into a bit today. So you can do anything you can do with a computer, basically. Clearly, this is not necessarily as powerful as the $3,000 desktop you might have, but it doesn't mean it can't do a lot of things. But it actually can do a whole lot more than your desktop computer can do. And those are some of the things I'm going to touch on today. So Raspberry Pi is also a company. There's two companies, actually. So one is a nonprofit, which was the original. It's called the Raspberry Pi Foundation now. They basically lead up the education side of the Raspberry Pis. So where you learn, where you get documentation from, where you can take classes. And now there's a for-profit company called Raspberry Pi. So that's the .com, the other one's the .org. They're UK based, and they're the ones who are selling the hardware, profiting from it, and creating the software that you use, which would be the operating system that you install in here. Their mission initially was to build an inexpensive computer to teach computer science in the education and maybe underprivileged societies that can't afford computers, and was hugely successful. And they did such a great job with it that the commercial market started using these. And they're used in a lot of commercial products, a lot of facilities today, manufacturing. We'll talk a little bit about that later. They built products that especially for them. So they're a pretty successful company. There's been news in the past couple of months that they look like they're going to have an IPO coming up either this year or the beginning of next year. I think they're valued at about $500 million, the for-profit side. So let's meet the most recent Raspberry Pi. It's number 5. In a few minutes, we're going to start at what 1 was like, and 2 and 3. We're going to go through a little history of them. But let's start with the one that's out in the market today that you may or may not be able to find because they've been hard to get over the past few years. But this is basically a 2.4 gigahertz quad-core ARM CPU. If that doesn't mean anything to you, that's fine. It's a pretty decent chip for the size it is. It also has a GPU, and it comes with 4 gigs or 8 gigs of RAM. The one that I have here is an 8 gig model. And like I mentioned before, 2 4K HDMI ports, which is pretty good. And it has Wi-Fi, Bluetooth Lite, and a couple more specs on them. And these are common through all of these Pis. It has a micro SD slot, which we'll talk about a little bit later. I'm going to stick this little slot inside here. They all have them. This one has 4 USB ports, 2 3.0s, has a gigabit Ethernet port, and the new 5 has a PCI interface on the bottom. So you can plug additional peripherals into it. What does it run for an operating system? Because this is a computer, so it's not running Windows, it's not running Mac OS, it's running variants of Linux, okay? Which is how I first get introduced to Linux. So Raspberry Pi has their own operating system called Raspberry Pi OS, which is the one that they recommend you install right away to get up and running. But there are other versions of the OS that you can run, Ubuntu, Debian, Fedora. Basically, almost all of the popular Linux distributions have versions that run on a Pi. And you can run it either as a desktop computer or like a server where it doesn't have a browser interface at all. You just connect to it through the command line. All depends on what you're going to want to do with it. So one of the things I'm going to talk about today is the superpowers of the Raspberry Pi. To me, this is the first very superpower. What makes this thing incredibly awesome? And it seemed like a very simple thing. And to call this a superpower sounds kind of silly up front. But I'll explain why in a second. So I mentioned a minute ago it has a micro SD card. So I assume everyone knows what a micro SD card is. I don't think I even have one out right now, but a little tiny card you put in a camera or something. You can see it there. And why this is a superpower is because that's all you need to run one of these. It's the disk drive, the hard drive is one of those little cards. And it's super easy to install an operating system, slide it in that little hole and turn it on. So here's an example here. I got a few screenshots of when you get a Raspberry Pi for the first time, you need to set up one of these little SD cards, install it. And all you do is on another computer that you don't have running yet, you install this app called Raspberry Pi Imager. And then you just go through some prompts here. So you can see here, I choose the operating system I want, and there's a bunch of different variants. I could have a desktop version with all kinds of software installed, a spreadsheet, a word processor. I could install a different version that has minimal software installed. I could also install like a server version that has no desktop at all. It's command driven. You also have the option to, I mentioned earlier, you can install some different variants of operating systems like Ubuntu, all from this one little tool. You also have the ability to install like software that takes over the whole pie and it's used for one purpose. Like if you want to run a home automation system, like Home Assistant, you could install it right on that little card, turn it on, and it's up and running. So why this is, I consider superpower, is these little SD cards, in the grand scheme of things, don't cost a whole lot of money, and you can get them as big as you want, or as slow or as fast as you want. But you can have a little, I have a little folder there that I have all different versions of operating systems and different configurations and different types of software, and I just unplug it and plug it in, it's up and running. If it crashes or you do something to destroy it, it's not a big deal. You just now burn one of these other CDs or overwrite the one you have and slide it back in and turn it on. That's hard to do in any other computer. You can't just switch operating systems real quick. That's why I consider that a superpower. It's one of the reasons to get one of these and start to play with it. Because you can try different things very easily and very quickly. It takes you less than 10 minutes to burn the new micro SD card, slide it in, and boot it up. So it's a lot of fun. Now, in addition to having the little SD card, because as you can imagine, or maybe you can't imagine, it's not the fastest way to run a computer when it's reading and writing to that SD card. They're faster than they were 5 or 6 years ago. You can get some that work pretty good, but you also may want to have a lot of storage and something more reliable, because the SD cards, they're not super reliable. After a couple of years, they may not run anymore. So you do have other options. You have USB ports on here. So you can plug in a SSD on a USB cable, plug it in here, and you can use that as data. You can also set it up as your bootable disk, so you don't even need the micro SD. So you make the USB drive bootable, you plug it in, and you're up and running. And with the 5 now, I mentioned earlier, we have a PCIe interface. It says interview there, that should say interface. And I've connected on this Pi at the bottom, you can't really see it, but I'll pass this around. I've got an M2 drive in here that's 500 gigabytes, and it is my bootable drive. That's about as fast as I'm going to be able to get on a device like this. So if anyone wants to take a look at this, just don't drop it. It should still survive if you drop it, but so that's an example of taking, once you've got a Raspberry Pi that you want to do something permanent with. Let's say you want it as a permanent desktop, or you're going to use it as a permanent home automation server for your smart devices. You probably want to upgrade, get rid of the SD card, and use one of those 2 other options that I have for you, because you're going to need more space and have it be more reliable. So this is that. That's not my exact Pi, but it's exactly how mine's configured. Superpower 2 on a Raspberry Pi. What makes them so different to me is the GPIO pins. So if you look at a Pi, yeah, you can't really tell. This is not a great shot here, but there's these 40 pins that are here. And if you're looking at the Pi that's passing around, you can see them better from this angle. There's 40 pins here. These are general purpose input-output pins. And what they're for is they're to connect your Pi to other devices, sensors, motors, that kind of thing. And allows you to have your Pi interact in the physical world. So you could read a temperature and humidity sensor that you've connected to this device. That makes this very unique. You can't do that with a regular computer. So that's what makes these things really powerful. And the kinds of things you could do, if you look here, there's a picture of a Pi, that's an original. And you can see that it's connected with these wires from the GPIO pins, and it's connected to some lights, and there's some code that's running that's doing something here that someone's doing. So you've now taken this general computer, and now you're interacting with the physical world. If you're interested in some basic electronics or robots, here's an example of a robot that is being powered by a Raspberry Pi here. You can see it connected to the top. So that's the second superpower. You're not going to do that with your Mac. All right, so we kind of got a feel for what a Raspberry Pi is. I'm going to go into a little bit of history and some of the models because they kind of come up with like three model lines here. Um, I'm going to go through these very quickly, but I will have a test at the end, so you have to memorize this stuff. This is just give you an idea. So the very first one, and that's actually the wrong photo. That is not the first one in the picture. This is the first one. You can tell because it has the yellow and the blue connectors here. So this was a single, so the 5 that we just looked at was 4 core, 2.4 gigahertz. The original is 700 megahertz, significantly slower, and 1 core in the CPU, and had 512 megabytes of RAM. No Wi-Fi. And this thing was $35 at the time, which wasn't bad still even today. The prices haven't changed all that much for the elementary models, for the lower end models. So that was 14 years ago. I'm going to go each year by year, and I'm just identifying the upgrades they made. So the following year, they wanted to make a more affordable option than the $25, $35, and they came out with a $25 model. They removed the networking because some people are just connecting it to a robot. There's no need for it to be online, so they removed the networking. They removed all but one USB port because there were 2 originally. So it was smaller and thinner, and it was $10 less, and it had half the memory too. So now we're advanced 1 year. Another year, the next year, they came out with a B model, B plus, pretty much the same. The big difference, and this carried forward till today, the original model had 26 pin, and that picture's wrong again, sorry about that, had 26 GPIO pins, and 2 years later they increased it to 40, and there's still 40 today. So you can see these here. So if you want to have to take a look at the original, you'll see there's only 26. So they increased it. That was one of the bigger changes. And each year they just slowly increased the CPU power and the RAM. So a year later, we've got now 900 megahertz. We're up to 1 gig of memory, and we're still at $35. Haven't changed. 2015, they did something super cool. They came up with one because it's a pretty big. This is a small computer, but if you're connecting it to robots and stuff, it's kind of big. So they came up with something half the size. It's actually like a third the size. It's called a Raspberry Pi Zero. They still make these today too. So they basically have a full size, which is this big, and then they call it half size. It's like a third size, and this is the Raspberry Pi Zero. Still the 40 pins. Still, this one has 2 HDMI ports. Not sure why you'd want those on a little device this big. It's got a little less memory. Still has the micro SD, so it generally works the same. If you wrote code or stuff or installed operating system on this one, you could do exactly the same thing on this one. It's just a smaller footprint, a little less power. And look at the price. $5. That's what they sold this thing for, $5. So they've stuck with their mission 3 years later. They're trying to make something affordable. You can put in your hands. It's easily for everyone to get to, and it's very well supported. 2016, they keep going with the full size one, keep increasing it. So now we've introduced Wi-Fi and Bluetooth. So it took 4 years for us to get Wi-Fi on these devices. Other than that, it's pretty much the same device. 2017, they took the small one and they added a W to that and added Wi-Fi and Bluetooth to that. And look they doubled the price to $10. 2018, just keep increasing the capabilities. It's up to 1.4 gigahertz. The RAM, the type of RAM they used improved, so it got faster. And then in 2019, they took a big step forward with the quad-core processors, and they offered a lot more RAM, 248 gigabytes, and they were kind of positioning this one as a desktop replacement. Now, you can't really replace your current desktop with one of these, but you could use it as a desktop. So I always say this could be a secondary desktop for you, probably not a primary. But that's how they kind of marketed this. Still, if you notice, it's still $35 for the base level. which is 2 GB of RAM, which is still a lot depending on what you're trying to do with these things. If you're using it for a home server for something, for media, that's probably fine. You didn't need to go up to the 8 GB unless you're trying to use it as a desktop computer. So they did that in 2019, 2021, 2 years later. They took that half size, the Zero, and they just improved the performance on it with a better CPU and faster RAM, and it went up to $15. Now, that's basically the whole line of computers, except for a couple that we've left off that I'm just going to talk about quick here. When they came up with the 4, I mentioned that they tried to talk about this as a desktop computer you could use it for. It's configured for it. And shortly after they released it, they came out with this, which is the Pi 400. It's basically the same guts of that Raspberry Pi, but it comes in a keyboard. So you don't have to have an additional keyboard. Everything else is the same. I think it's only 4 gigs. You couldn't get it in 8 gigs. And the GPIO pins are still accessible here. So you could still do any connecting to physical devices. You've got all your ports here. They're just sort of configured different, but it's basically the same computer. This was a good way to introduce. I know a few people who've used these and still are today as like a secondary computer in the house for an older person or a kid who doesn't need a lot of power. It's just super convenient to have the keyboard right there. You just plug in a mouse and a monitor, and you're up and running. And this costs $75 still today for this without, and you could also get it with a mouse. Let's see if I get this right. I think you can get it with a mouse and something else, and it costs $100. Like there's a $100 kit and a $75 kit. I don't remember the pricing. Still available today. Two more kinds of computers they came out with. I mentioned earlier that the Raspberry Pi became very popular in the commercial world. But in the commercial world, when you're putting this inside of a big manufacturing machine, you don't necessarily need all these input-output devices. So they basically came out with the Raspberry Pi that doesn't have any input and output devices. It's got everything else there. It's called a compute module. So you get the same CPU, the RAM, and everything, and basically it connects to the outside world on the bottom through these connectors. So people are using these in manufacturing. They're extremely popular for in the commercial space. And this is a big driver in their business today, financially. So there's compute modules, and the last one we have here is a product they came out with in 2021, I think, or 2020. 2020. And this is now a microcontroller, not a computer. So there's a little bit of a difference between what a microcontroller is and a computer. So the microcontroller includes the processor, the memory, and the input-output. It's this guy right here. But it doesn't have an operating system installed on it. It's not designed, there's no keyboard, mouse, or things like that. The microcontroller is probably one of the most popular computing devices in the world today, because microcontrollers basically control most of the stuff you see electronically. There's a microcontroller in your refrigerator, there's one in your washer and dryer, in your DVD player, or in your remote control, and that's what this is. I'll pass these around too. There's 2 versions of these. There's one without Wi-Fi and there's one with Wi-Fi. You can always tell the Wi-Fi is got the silver on it. But these cost like $4 and $6. So if you're interested in doing microcontroller programming, so they're like one-purpose device. You build it to control lights or to control circuits. They started making these and they're extremely popular. That's the whole line of Raspberry Pi products. And there's a few observations after we looked through. I kind of made you suffer through all those slides there. A few things to notice is that from 2012 to today, they're extremely steady and consistent in basically the way this thing looks, the size of it, and how it works. And I mentioned earlier that you could get the original model, install Raspberry Pi OS on it today, and it still runs. They're backward compatible right for 14 years. So if you wrote code and programs 14 years ago, they will still run on the old Pi or the new Pi today. That's very unheard of in the computing world. It's part of what Linux is all about and part of what they are about as a company. So really, they have minimal product lines, which is, it seemed like a lot as I was going through, but they really have the big board, the half-size board, the computing module, and the Picos. That's all they really sell, and they just keep improving on them every year. The third superpower is the price. These are generally affordable for everybody. And every one is still available today, except for the original and the Pi 2. All the other models you can still buy. The 3, the 4, the 5, if you can get your hands on the 5. But they're all available today. So I bought a Pi, now what? So now what am I going to do with it? So we're going to transition into things you can do with a Raspberry Pi and a Pi Pico. So the first thing, a secondary computer. So even the latest model, the 5, supercharged, like I have floating around here somewhere, unless someone pocketed it. Oh, it's up there. It's an adequate desktop machine. So what I mean by that, if you're doing internet browsing, email, YouTube videos that aren't 4K, although it runs 4K, just not, you know, a lot of frame drops. Basic word processing, spreadsheets, presentations, you could completely use one of those things and be fine. Really, it will work. So I've used those for weeks on end without any trouble. I've done programming in Drupal on those just as an experiment, so they work. So they could be the primary computer for the right person. So with the superpower of the SD card, if you have someone in your family that gets on the computer and every 2 months has like destroyed it or just installed like bad viruses and just click on things they shouldn't, it's a great solution for someone like that who's just on Facebook and stuff, clicking on things they shouldn't, because you just have one of those little SD cards ready. When they mess up their machine, you swap out the SD card, they back up and running. It's a great solution for something like that. If you have a young person that you're trying to get into technology, it's something you can put in front of them and not worry about them doing any harm, and you haven't invested a lot of money in something, right? Let them tinker with it. Let them install any OS they want. Let them learn what Linux is about. Have them do some electronics with the GPIO pins and stuff. It's a great way to get people sort of moving on these things. I'm going to talk about resources at the end on how to move forward on that approach, but we'll get back to that at the end. So first, potential use of secondary computer. So here's if you have never seen, so a lot of people say, well, it's Linux. How's someone going to get used to Linux? When I've taken that Pi 400 with the keyboard and put it in front of someone who had been using Windows for years, there was no hesitation at all. They didn't even know they were using something different. The colors are different, but it works exactly the same way these days. There's not like a big difference between these desktop operating systems. So this is a screenshot of what Ubuntu looks like on the Pi. It's very straightforward. And basically, for the right person, you get rid of all the stuff you don't want them touching from the icons, and they just have their browser, their email, and that kind of thing. Another great use is if you're interested in Linux, but you have one computer at home, you don't want to, you can't remove whatever you have on there. You're going to use your Mac or your Windows, and you just want something to learn some Linux on. You don't even need a Raspberry Pi 5. Get a 4 with a couple of gigs of memory, and you can teach yourself Linux. You can learn it. You can learn it not just the desktop side, but you can start to learn Linux administration on the server side. If you're interested in that kind of thing, it's a great way to do it. Because this little box running Linux is no different than a $10,000 server computer running Linux. It's exactly the same thing. It's just a little less power, or a lot less power. But you can do all the same things. One of the very first things I did when I got the Raspberry Pi, and this picture kind of shows you this. This is in my office. This is still sitting on a shelf in my office today running. But I got for Christmas, my wife didn't know what the hell I was asking for, but I gave her the link to get me this little rack. And these are Raspberry Pi 3s in here at the time. I think this picture was taken. And I shoved all these in there because I wanted to learn about how to use Ansible, which is a server management software, and manage these servers remotely. I set them up as Linux servers, and I taught myself how to do that kind of stuff with Raspberry Pis. And these were $35 each at the time, and the rack was probably another 20 bucks. And I could create this really sophisticated environment, and it didn't cost me a lot of money. And you know what? I didn't care if I screwed it up because I had that magic power, right? I just reformat the SD and stick it back in. It was beautiful. Interested in learning Kubernetes or Docker? This is the way to go first. A lot of people will go to an online service and rent space. You can just get it free from Linode or something. You can get a Linode server. There's something better about having that physical thing in your hand that you're gonna plug in. You can see the lights blinking. There's something special about it. So, and at the top, right there, at this point, I had bought a Raspberry Pi 4, and this is running my home automation system. And there's a USB cable going to the SD drive connected to it. Another use. Has anybody ever heard of Pi-hole? So Pi-hole is a piece of software for Linux that is designed for Raspberry Pi, but it's an ad blocking system at the network level. Really straightforward to install. Even if you're a newbie, you just follow some instructions, and you could take your home network and change and put ad blocking on the whole thing. So if you use something like this, there's a huge difference. I don't even like to use my browser outside my house anymore. When you go to news sites and stuff, there's so much ads there, you can't even find the text. At home, I don't see that. They're completely gone. I don't see any of that stuff at home because I'm running Pi-hole. And it basically sits my router to my internet provider, and this thing sits right after that, and then my wireless router goes into that, and it blocks viruses and stuff too. Great tool. It's free. It's open source. It's probably one of the number one things people use a Raspberry Pi for. The very first thing they use or try is doing something like this. You will actually notice because you connect it at the source of your network, your wireless network in your house and your phones and all that stuff is much faster too now because it's blocking all that stuff at the Pi-hole. None of that stuff is coming down into your network. Great way to start using a Raspberry Pi. Another thing here, a media center. So a media center it's again software. You can install it on a Pi or another computer, but it's basically a way to store videos, CDs, and serve them in your home or outside your home. The reason I got into this originally was my father, since I was young, or since my kids were babies, they're almost 30 now, but since my kids were babies, my father always had the camcorder over his shoulder on all the holidays and stuff, taking videos, VHS. He never showed them to us ever. We didn't even know where they went. What he would be doing, he would be sending them to his sister who lived in Florida. So about 4 years ago, whenever I started to get into this, I get a call from her once saying, you know what? I've got boxes of VHS from your father from the last 20 years. Do you want them? I'm like, yeah, I do. So I took all those VHS, I converted them all to digital, and I stored them I loaded up this media center. And they're videos that are sitting there that anyone in my family now, in my family, extended family, they all have access to. They can watch these videos from 25 years ago. It's a lot of fun. And I've also taken DVDs and stuff and burn it to them. So a media center is a way to store your media in one place, and you can access it remotely from your TV, from your devices, or remotely. I've got some links to different software packages there that you could use. I'm using Jellyfin now. I used to use Plex, but that's it's a proprietary software, and I found Jellyfin. It's open source and works a little better for me. So this is a picture from a browser. I can see videos, 2001 of my daughter doing something, and that's a thumbnail of all the videos. It's pretty cool. So a media center is another big use for a Raspberry Pi. VPN. If anyone ever has a need, I think everyone's heard VPN now. They advertise them everywhere. But what I use a VPN for is I have a VPN running on a Pi in my house. So when I'm out of the house, I can securely connect back into my home and work. So I don't have to have all my work with me all the time. I just need an internet connection, and I VPN into my house, and I know it's secure, and I can connect to all my machines from outside the house. Great use of the Raspberry Pi. Again, it's relatively easy to set up. Just follow instructions. The application that I'm using is called Pi VPN. It's kind of a install it, run it. You get a little nervous with some of the configuration on that one, but if it doesn't work, you unplug it. You try it again. That's what's nice about this. Another use, home automation server. Anyone have smart devices in their house? Well, you could install something like Home Assistant on a Raspberry Pi in your house and use that to control all your smart devices. So you don't need to use like some of the proprietary Apple or Philips Hues. You can basically use an open source one that will connect to all those different devices and control them. And you can end up like having a screen like this that kind of shows what the temperature is in your house, what the status of your lights are, and that kind of thing. Another great use for the Pi. If you're into old gaming, you could retro game. So you can install these. RetroPie is one of these softwares you can install. There's lots of different. I'm not a gamer much, so I haven't done a lot of this. I just kind of tried it a few times. But if you're into the old Atari games or Nintendo games, you can actually install them on the Raspberry Pi in this emulation mode and run them like you would have run them 15 years ago. So for things like this and all the other stuff, if you need help with this stuff, there's so many people online on YouTube that will answer all your questions and walk you through how to set all these things up. It's crazy. So now let's jump over to the superpower of the GPIO. So with any Raspberry Pi or Pico, they all have these GPIO pins. So you can do lots of projects with them. I'm going to give you a few examples of projects that I've done. But if you go to Google and just search for Raspberry Pi projects, you can get lots of ideas. You mentioned getting your kids interested. This could be a way to get them interested, but to find a project that's interesting. So the end result is what they're looking at, not necessarily learning something new. So I'm going to give you some probably boring examples of things I've done. I haven't done any robotics. It's one of those things I haven't got into. I'm always tempted by it, but one of these days I'll start it. Most of my stuff is usually practical. So this is an example of me doing something practical. So my basement has a dehumidifier in it, like most people that live up in this region. And my dehumidifier would go on at 51 degrees, 51% humidity, and the sensor in it stopped working. So I built one. I basically took a Raspberry Pi Pico. I connected to it a humidity and temperature sensor. And I also connected to it a little LED display so I could see what the current values were. And I put it in my basement. But that wasn't really the best part about this. What I did was I connected it to my home automation system, that whenever the humidity went above 51 degrees, it would turn on the outlet that the dehumidifier was plugged into. This has been working for 3 years flawlessly. Still running today. Another example, and yeah, my finished products don't look all that good. As you saw, this one doesn't look so professional. But this picture is actually what is sitting on my coffee table on my side of the couch in my living room. That device, and this has been here for about 2 years. And what this does is, I have most of the lights in my house are controlled by my smart system automation. They go off and on at daylight or certain times on a schedule. But there are some times where I just want the lights off. I'm sitting in the living room. So I could say, Alexa, turn off the table lamp. Alexa, turn off the living room lights. I just find that annoying. So I ended up putting these two buttons with a Pi Pico here. And I'll talk about that little LED in a minute. But these buttons here do two things. You can press them, because it's a button. You press it up and down, and there's also an LED light in there that you can control. You control those two things independently in here. So basically what I do is, and this kind of ties a lot of things together. I've got this little thing that I built, and it's got software in here written in Python. This doesn't actually turn the lights on or off. That's not what this does. This sends out a message to my network, to this thing here. Has anyone ever heard of MQTT? It's a messaging protocol where you basically, on a network, you can send a message. You just say, hey, I want the lights on. And this server takes that message and sends it out to anyone who cares. When I say anyone, any of the devices. So this is my home assistant that controls the lights. That's in a Raspberry Pi. And a different Pi is this MQTT server that all it does is take messages and send messages back and forth. And the way this works is, the blue one is for the lamp next to me. When I push that light, this sends a message out that says turn, and it's a string. I think I got a screenshot and it's a string. Yeah, it says, the string looks exactly like this. Living room, standing lamp, turn on. It just sends out that message. And then over here, my home automation system is saying, hey, if you ever see this message come through, turn the light on. That's what it does. But then my home automation system says, hey, when I've turned on the light, if it went on, send out a message that says the standing room light is on. My Pico is listening for this message. When it sees that message, it turns that little LED on. So that LED is only on if the light is on. It's not because I push the button. So if there's something else in my house that turns on the living room light, that light will come on even though I didn't touch the button. Or if for some reason that light went off, like at 11:15 at night, all the lights go off, this light will turn off. So it's the kind of stuff you can do. So there's a Raspberry Pi Pico here with Python code. It's sending messages out here to this Raspberry Pi. That's a simple message server. And then this is, the home automation, home assistant, that is just like a GUI screen that I set up these messages to turn lights on and off. Not super complicated. And the last little piece here, I got this little light here. That little LED sitting in the corner is connected to my motion sensors in my basement. So I've got 2 motion sensors in my basement. So because when my daughters were home, it was always a pain in the neck that they leave the lights on down there. So I basically put a few motion sensors in there. So when someone walks down in the basement, turn the lights on. If they go in the boiler room, turn the lights on. And if it's quiet, no movement for 15 minutes, turn them off. So this light gets activated anytime the motion sensor is triggered. And for me these days, it's basically, I know my cats are down there because there's no one else home anymore. So it's my cat indicator. So let's talk about some resources.
What was the second button?
Oh, it was a second lamp. So two lamps. So this project took me like almost a month to do because I ended up writing a whole Python library that I can install on any device and not have to code this kind of thing anymore. Like I could add 2 more buttons in here and have this thing working in 5 minutes because I just call a new function in the Python and I send a message string and it talks to the server. So that was like a real fun project for me, and it still looks as lame as it does, just like that. So when you want to, after you go and buy your Pi from somewhere and you need to learn more, one of the great things about Raspberry Pi is the support you get. I don't mean like calling 1-800 support. I mean the resources online are immense. So the Raspberry Foundation, the nonprofit side, is all about education and learning. If you go to raspberrypi.org, you'll see there's a learning tab there, teach tab. There is so many resources there and projects there. Basically, it's awesome. And there's also a community you can join, a forum community for free. Whenever you have a question, you post it there, someone will get back to you within 5 minutes. There's thousands of people on the thing every day, and they're all so nice and helpful. There's also Raspberry Pi Press. This is also controlled by the foundation, and they have lots of books and magazines that you can get subscriptions for. Or, if you don't want to pay for them, a really great thing they have is once you install Raspberry Pi, if you install their operating system, they install an app called Bookshelf that anything they've printed that you could buy, you can download as a PDF. And you can find all these by doing a Google search to look for them, but they don't make them super easy to find from a browser. But if you install the Bookstore app, everything is there. And they've got these books called Getting Started. Did I put any in here? Let me just jump to my browser for a second. Raspberry Pi. Getting Started. That should be good. So right here. We'll find the book. PDF. They have these books that you can buy that are fantastic. They're like $14. It's a beginner guide that walk you through learning all of these things. And they're written for every age. So from 8 to 50, 60. And you can buy these for like $14, but every single one of them is available in a PDF. So you can see that it just takes you through all the elementary steps. They have one for Raspberry Pi, they have one for the Pico, and they update them about every 2 years as the models change. Fantastic resources. And one more place to go is when you go to raspberrypi.com, or if you go to the .org, there's always a link that says documentation. And they've got some of the best even deep documentation here on the devices. Like if you're coding serious stuff and you need help with interrupts and how this thing is working underneath, it's really fantastic documentation. It's all there. And you'll never always go to YouTube first too. There's tons of resources there. People there are so helpful, and there's lots of regular podcasts and stuff, video podcasts that do projects regularly and talk about these devices. And I've used up all my time. I actually went over, didn't I? By 4 minutes. Any questions? Well, because we can save questions for later, so just have fun. You could also go to some of a lot of the projects I've done. I've posted on my blog. If you go to my website, you'll see examples of stuff there, and a lot of the code I've published in GitHub too, if you're interested in it. That's it. Hope you enjoyed. Hope you get a pie. Yeah. And I'll hang around if anyone has any questions.
Can we come see your house?